Hi, welcome back to this video tutorial series where I am coding a convolutional neural network from scratch in Java. Where we left off last episode, we just finished off our convolution layer, so we've got backpropagation working. And now that we've got all of our layers together, it's time to put them into a network. I'm going to create a new package here called network. And in this package, I'm going to create a new class called neural network. So, a couple of things we need in our neural network. First of all, we need a collection of layers. These will all be linked together. An input image will go into the first layer, and an output guess will come out the last layer. So we need a way of working out what our network's guess was. We need a way of comparing that guess to the expected result, and we also need a way to test and train our network on a large collection of images. For this class, we're just going to make a pretty simple constructor. But before we do that, let's define a list of layers. So this is our abstract class, and this is the really nice thing about using an abstract class, is that we don't really care about what our layers actually are, so long as they meet the requirements for being a layer. Cool, and so let's go ahead and create a constructor. And now what we're going to do is create a function called link layers that is going to set the previous and next fields in our layers to be the previous and next layers. So if we come and look in our layers abstract class, we have these functions, these get next layer, get previous layer, set previous layer. And of course these protected fields, next layer and previous layer. So let's go ahead and create a function called link layers. Now, first case we need to consider is what if there are there's only one layer. We're not going to do anything in the case that there is one or less layers. Otherwise, we're going to move through all of our layers, and for I equals 0, for example the first layer, we're going to set the next layer. For all the middle layers we're going to set the next and previous layers, and for the last layer we are only going to set the previous layers. Cool, and that's all we need for that function. So we're going to call this in our constructor. After we've set the layers, we're going to link them. Sweet, so now our layers are all linked up after constructing this neural network. Let's think a little bit about our errors and guessing process. Cool, so we're going to create a function called getErrors. And what this function is going to do is it is going to take the correct answer. This is an integer, which corresponds to what class in the network output we would expect the highest output to be. In fact, we expect that output to equal to 1, 1 corresponding to 100% certainty, and the output from the network. So this would be our output from our final fully connected layer that gets propagated all the way back up to the top of the network. So if we come have a look in our fully connected layer, this get output function returns our double, and remember this propagates all the way down to the next layer, next layer, next layer. Now our final layer will always be a fully connected layer, so our final output would always be the result of this fully connected forward pass. And if you recall, this is that process of multiplying stuff by weights, and we eventually want to return an output whose vector length is equal to the number of classes we're guessing. Cool, so back in here, first of all we want to figure out how many classes we guessed. Alright, so now we're going to create a vector that represents our expected output from the network. This is essentially all zeros except for L1, where the correct answer should be located. Now, because we don't actually want the expected value, we want the actual output minus the expected value, and that will give us the error. We're going to add our network output to our expected. However, first we're going to multiply our expected value by -1 because we're kind of subtracting, expected versus actual to find the difference between them. Sweet, and then we're just going to return this. So to clarify getting our errors, here we've taken the network output and the expected answer. We've created a vector that represents the expected answer with zeros in every column corresponding to class, except for the one correct one, dictated by this correct answer. And then we have subtracted that from the actual output to find the difference between them. Cool, alright, and now what we need is a way to figure out what our network's guess was, and this way when we test it we can say, was your guess correct, was it incorrect? So to figure out what its guess was, we're going to take whatever the highest value was for this network output. So first of all we're going to create a function that is get the max index of this 1D vector. So now I've got this cute little function that just gets the maximum of a vector. This works out really nice because with the MNIST data, of course, we are working with digits. So when this returns the index of the maximum, it is actually returning the guess. So if we get a 0 back from this getMax index, this will correspond to the 0 digit. So that's pretty cool. Alright, so now we want to create our guess function, in which we will actually call getOutput on our neural network, get the output, work out what its best guess was, and return that guess. Now, the reason I'm converting this input image, extracting the data and getting it into this list format, even though there's only one image, is because that is how our network needs to take an input. So each layer will either take this list of double or the vector. In our case, because we're dealing with images, we always want it to be in this matrix, list of matrix form. So then we're going to get our out and call our network to make a guess. Cool, so we're calling our first layer and telling it to get output, and remember it will get output from its own layer and then send that down to the next. And similarly, stack gets called all the way back up. We get our output from our final convolution layer. Now, our guess. Now, guess is just the maximum index of this output. And now let's create a test function that uses this guess method. So here we're going to count how many guesses we got correct for each image in our input list. And then if the guess was correct, we increase the count of correct. And then what our return here is going to be is basically a percentage of how many we got correct. I am just going to cast correct to a float to make sure that everything stays nice. Cool, so that's our test function, super easy. And our train function is going to be really similar, except we are actually going to do the backpropagation. So as we did in our guess function, we are going to grab the data from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that list format that our layers like. And then we're going to get the output. And then we're going to get the output from the image and turn it into that l But then we are also going to get the error. And then finally we're going to do backpropagation starting at our last layer. Awesome, so we're starting our backpropagation, feeding in this initial error into our last layer. And that is kind of all we need for this neural network class. Now I'm going to create a builder so that we can add layers really easily. But really briefly I want to talk about something that tends to happen, which is a scaling issue where your sums become so big because your input images are so big and there's so many layers that we actually need to scale down our initial input so that by the time it gets out and we're trying to correct, we're not rapidly over and under correcting and kind of swinging wildly around the correct answer. This is something that I've run into, so I'm just going to create a scaling factor for this neural network, and that will scale the initial values of each input down by a certain factor. You could replace this with a scaling layer that scales backpropagation and forward propagation results, and shove that in the middle of your network if you wanted and tweak around, see what works for you. But I found this to kind of fix a lot of problems. So we're going to have a double here that is going to be our scale factor. So here, before we add this image to the list, we're just going to scale it down. So that's going to be multiply the image.getData by our scalar, which is going to be 1 divided by our scale factor. And we're going to do the same thing for our training. And I guess we want this neural network to have a scale factor input. Sweet as. So now let's talk about adding layers to our neural network. And to do this, we're going to create a new class called Network Builder. Now, I'm not convinced that I'm using the builder class, the builder pattern correctly here. It's been a while since I studied it, but basically the idea is that if we have a really complicated class, such as our network with lots of different parts that need to be added in certain orders and everything needs to be the certain size, if we can create a class that simplifies that whole process and kind of takes away that logic and puts it somewhere hidden, then that is a really good thing to do to save us time and headache. So, network builder. First of all, it's going to have a neural network. It's going to have the number of input rows and input columns. And it's going to have our list of layers. So let's go ahead and create a constructor for this. Now we want to create functions for adding each layer type. So let's start with our convolution layer. Cool, so this function just has all of the inputs that we need for our convolution layer constructor. Cool, so now we need to know if this is going to be our first layer. If it is our first layer, our input length for this layer will be 1, because we will only be giving it one image at the very top. Awesome, so we've added here, if this is our first layer, i.e. if this layer's list is empty, a new convolution layer with our input length, i.e. the list length is 1, and the rows and columns are the same as the input rows and columns for the whole network. Or else we will just get the dimensions, the output dimensions from the previous layer and use those to inform our input dimensions for this layer. Sweet as. And now we're going to do something really similar for the max pool layer. So now for our fully connected layer, we do the same process. Cool, so now we would like to build our neural network. Cool, so now let's put it all together and build our neural network. Again, there are lots of places for checks here. For example, checking whether our last layer is the fully connected layer, checking whether the output length of our final fully connected layer equals the number of classes that we want our network to guess. All of this checking is really good, but for the purposes of time and simplicity, I'm not doing that checking in this tutorial. Okay, so now we need to give our network a scale factor. So this is something I forgot to do. Let's add scale factor here. Cool, so now we set our scale factor in the constructor as well. And we can go ahead and build this network. Oh, problem in the network builder. So we need to initialize our layers list. Let's go ahead and do that as well. Alrighty, finally, the moment that we've all been building up to. Let's take a look in our main function and actually build a network. So currently we've got our test data here. Let's create another variable to store the path for our training data. Before we do this, I'm going to add a little print statement so that we know that our main function is running. It might take a while to load in all of this data. Sweet, and now what we're going to do is spit out the size of our train and test data sets. Then we're going to build a network. This particular network is just going to have one convolution layer, one max pool layer, and then one fully connected layer at the end. And for our scale factor, I'm going to try 256 times 100, so pretty big. Cool, so let's go ahead and add a convolution layer to our builder. We're going to say maybe 8 filters with a size of 5. Keep the step size at 1 for now. Our learning rate, a good starting point is often 0.1, and then a seed. Let's create a seed up here. I'm just going to call this 1, 2, 3. And then we're going to add our max pool layer. And then we'll add our final fully connected layer. Our out length is 10 because that's the number of digits there are. And our learning rate will go 0.1 again. Awesome, and then we're going to build our neural network. We're going to run an initial test to see how successful it is without any training. We expect this number to be around 10%, so around 0.1. And then we're going to print that success rate. Sweet, and then we're going to shuffle our training images, and this is important so that we're not introducing bias into the network. Maybe all the 7s are grouped together. You know, we don't want to deal with that. Cool, so I think that's all done. And when I say all done, I really mean it. And I'm really nervous to hit play on this network. Let's see how we go. I did run into a bug, but I will edit that and fix that so that you guys don't run into the same bug. Alright, let's give this a run. Data loading, images train, images test. Oh, alright. We've tested. So pre-training success rate of only 0.7, so that's pretty lousy. Let's see if it can get better after some training. After one round of training, our network is guessing 86% of these numbers correctly. I'll let it run and see how close it gets after 3 rounds. But you can totally fiddle around with this. There's loads of stuff you can do to play around with here. I'm just gonna let this run. And with that, at 90.5% accuracy with our first neural network, I think I'll call it there.